Today, my second lecture about solar energy. The series is renewable energy sources. Now, discuss about solar energy. This is the second part of my video. Solar energy, the ultimate renewable sources. If we see my PPT, the sun has ultimate renewable resources. Second, radiant energy, nuclear fusion. This process occurring in the helium, deuterium, tritium, neutron energy. The sun's energy travels in waves to the earth radiations. What is solar energy? Originate with the thermonuclear fusion reaction occurring in the sun, represents the entire electromagnetic radiation, visible light, infrared, ultraviolet, X-rays and radio wave. The curve showing energy spectrum diagram, wavelength, left hand side short wave radiation, right hand side long wave radiation, X-rays, UV, visible, infrared radiation, micro radiation and radio waves, wave profile, sun's energy spectrum. You see only 400 nanometer to 700 nanometer, this is the visible region. Now, how much solar energy used? The surface receive about 47% of the total solar energy that reaches the earth. Only this amount is usable. The sun emits 100%, then transmitted only 24% direct solar, 17% absorbed, 25% is scattered, and atmosphere 9%, 6%, 10%. Solar energy utilization, solar electric, solar fuel, solar thermal. We discuss about later after this video in third part and second fourth part. Major use of solar energy: daylight, drying agricultural product, space heating, water heating, generating electrical power, concentrating solar power, photovoltaic. Daylighting, you see residential houses, buildings, commercial industry, office language. The big large glass used for efficient use of solar energy for lighting in day system, and we use only electric energy in night time, so we use efficiently solar energy. Drying agricultural products, water tank, vegetables. You see this PPT. Space heating through passive solar. This diagram shows the insulated panel at an angle. Orthos passive solar design, latitude 45 degree, roof pitch 30 degree. Heat absorbing panels, water, sun, winter sun angle, southern exposure, summer sun, winter sun, and control aperture, distribution, absorber, thermal mass. Active solar heating, solar collector, solar tubes, radiator, generating electrical power, concentrating solar power, trough system, power towers, heat exchanger plus steam turbine, photovoltaic, small scale building, kilowatt production, large scale utilities, megawatt production, photoelectric effect, power tower. Solar 1 CA, steam heat transfer 10 megawatt, solar 2 CA, molten salt heat transfer 10 megawatt, solar 3 Spain, molten salt heat transfer 15 megawatt. You see this diagram and then show this is the solar power, solar tower. This is the solar panel, and then reflection towards this tower, and then hot salt, and then steam generator, connected alternator, and convert electrical energy. The power versus time graph. Solar collector megawatt, the solar energy efficiently transmitted to the tower. The power is increased, and then power and then decrease under the time. This is the peak time. Concentrating solar power. Solar 2, this is the US picture of the solar tower, solar 2. Then more panel around this, and then reflectors, parabolic trough. Sunlight focused on heat transfer fluid, STF, which then runs steam turbine. Absorber tubes, inside this tube, reflectors, solar filled piping. Another diagram, this shows solar collectors, steam condenser, generator, superheated steam turbine, connected alternator, and then receiving water condensed and then again forced to cooling tower. This is the power generation diagram through steam by using solar radiation. This is the solar collector array. Okay, furnace, using in furnace hot water, cold water drainage system like this. Okay, uh, solar energy, sun transmitted radiation and then falls sun radiation on this solar collector, and then this heat up the drainage tank and the solar storage tank, and then hot water released out, yeah, by using heat exchanger, cold water, and furnace, concentrating solar power. This is again trough. Ivanpah Mojave Desert. The United States houses the largest CSP plant in the Mojave Desert. Ivanpah is operated by Energy. It uses 347,000 garage door size mirror and 173,500 heliostat. You see this picture. This is the image. Photovoltaic, another important, more cells connected in series and parallel. This is the some introduction about solar PV panel. This is the rectangular and circular form in this, and then closed up a PV cell. Okay, this is the now solar radiation, anti-reflective coating, transparent adhesive cover, glass front coating, current, and then glow bulb, n-type semiconductor, p-type semiconductor. This is back current. This is the close-up diagram, n-type front contact, close-up PN junction, back contact current, right? PV array, cell, module, and array. One cell and another cell connected in series and parallel module. Then there are different types of module connected in series. One, this is called array. So PV array component, PV cell, modules, and array. What is PV system component? Solar array. Now solar panel convert sunlight into electrical energy and then connected charge control to control the charge for AC and DC purpose, and charging the battery. We directly use DC and we convert, we use inverter and then use AC load. Remote PV power, bridge closed system. This is the folding back solar panel. Top countries for installed PV capacity like US Department of Energy NREL 2015 renewable energy data book. Global PV growth. Solar PV global capacity by country region 2005-15 227 gigawatt. Rest of the world: Italy, United States, Japan, China. Advantage of solar energy: clean and sustainable, free, provide electricity to remote places. Disadvantage of solar energy: less efficient, costly equipment, part-time, reliability depends on location, environmental impact of PV cell production. During cloudy days, this is not efficient because the sun not emits energy in the form in this time. During night time, this is not efficient, and more cover area. Global energy flow. This PPT shows net shortwave radiation like the red hub. Positive value represent energy moving toward the surface. Negative value represent energy moving away from the surface. Sorry. Sun, the ultimate source of energy. The energy from sun towards earth flows in the form of radiation. This is the convection, chromosphere, photosphere, solar wind, solar wind. Radiation, characteristic of radiation. Wavelength. What is wavelength? It is the distance between wave crust and trough. Amplitude, maximum magnitude covered by positive and negative cycle. Lowest part trough, upper part crust. The distance between two successive crust or trough is called wavelength. Radiation, wavelength, characteristic of radiation, the distance between wave crust. Amplitude, the height of the wave. The distance between wave crust, the height of the wave speed, constant speed of light 186,000 miles per second and 308 meter per second. Radiation, the wavelength of radiation determines this type. This is the UHV, VHF, AM, VLF, infrared, visible, ultra, X-ray. This is the wavelength micrometer. Radiations, the amplitude determines the intensity. The types, wavelength, intensity, amplitude of radiation depend on temperature. Ultraviolet and shorter wavelength, left hand side and right side, nearer infrared and longer wavelength. This is the visible region. Intensity of radiation. So sun is hot, short wave radiation. Earth is not. Radiation, a black body, an object that absorbs all radiation and emits the maximum amount of radiation at every wavelength. Not realistic. Ultraviolet and shorter wavelength, nearer infrared and longer wavelength. This is the visible radiations. Gray body, an object that emits a fraction emissivity of a black body radiation. More realistic. Radiation laws, Stephen Boltzmann law, very important law. The total amount of black body radiation emitted first is related to temperature, either sigma degree 4 for as well as sigma Stephen's constant. For a gray body, that it becomes I do epsilon sigma degree 4, where epsilon is the emissivity. This is the coefficient of intensity of the radiations. Radiation's law, Wien's law, another law. The wavelength of maximum black body emission is related to temperature, lambda maximum 2900 upon T. This is the temperature. Solar radiation and the earth, the solar constant, the amount of solar radiation hitting the earth. You know this picture. Area of surrounding sphere 6.36 Newton per 3 square per meter. Area of surrounding sphere 2.83 Newton ki power 23 square meter. 1.5 Newton per meter sun. 225 Newton per meter towards the Mars and Earth, and show picture. Solar radiation and the Earth orbit the sun electrically once per 3652.20. The farthest point aphelion. You read about aphelion means apart and closer parallel pass. Solar radiation and the Earth till the true cause of the season. Earth axis tilted. Now vernal equinox March 21 incoming solar energy equal in both hemisphere. Arctic 65.5, Cancer 23.5, Equator 0, Capricorn towards south, summer solstice 21 and 22 June northern hemisphere, and winter solstice 21 and 22 in the southern hemisphere. 22 incoming solar energy equal in both hemisphere. March and September. Solar radiation and the Earth, three factors contribute to the amount of incoming solar radiation: insolation, period of daylight, sun rays, noon time, length of day night, March 21, September 21, vernal and autumnal equinox. Period of daylight, this is summer solstice, this is the period of daylight, this is the winter solstice. Solar radiation and the Earth, three factors contribute the amount of incoming solar radiation. Second is solar angle. Solar angle, the same amount of light is distributed over a larger area in A than B. Effect of sun angle on surface of solar power. Power is reduced when beam is spread over a large area. Sun elevation angle is decreased. Reduction in power proportional to ratio x by y. Elevation alpha b, zenith angle x upon y sin A cos B. Orientation and tilt angle. Zenith, the sun, azimuth, sun, height, sun azimuth north, sun surface, tilt, gamma, alpha, theta. Solar radiation and the Earth, three factors contribute to the amount of incoming solar radiation. Beam depletion, solar angle, insolation, solar angle, beam depletion. First is period of daylight. Second is solar angle. Third is beam depletion. So now beam depletion, sun directly overhead, sun at sunset or surface. Let us see this PPT, and then you imagination, understanding. To estimate maximum solar power on the surface, start with the 1400 watt per meter square value at the top of the atmosphere and correct for absorption by the atmosphere into 0.8, spread out due to sun angle into sun elevation angle. Estimate maximum solar power for 25 Newton, 45 and 65. 25 Newton के लिए 1120, 45 Newton 1050 and 65 Newton. Latitude 25, 45, 30, 65, 75, maximum resolution 90, 80, 70, 60, 50. A good radiation sensor should show this response when a parallel light beam is pointed at the sensor for different angle. Response is linked to the zenith angle rather than the elevation angle and called cosine response. Global energy flows watt per meter square. Reflected solar radiation reflected by clouds and atmosphere by surface, incoming solar radiation, atmosphere by atmosphere, latent heat emitted by atmosphere, and outgoing long wave radiation, atmospheric window, greenhouse gases absorbed by surface, thermal evaporation, transpiration, and absorption, surface radiation absorbed by surface. All of the radiation structure global energy flows towards Earth. Solar energy potential. Energy from our sun 1372 watt per meter square is filtered through the atmosphere and is received at the surface at 1000 watt per square meter or less. Average is 345 watt per meter square. Air, cloud, rain, and has reduced the received surface energy. Captured is from heat, thermal energy, and by photovoltaic cell yielding direct electrical energy. Solar photovoltaic cell. What is solar cell? It is also known as photovoltaic cell (PV cell), a device that converts light energy, solar energy directly to electricity. The term solar cell is designed to capture energy from sunlight, whereas PV cell is referred to an unspecified light source. It is like a battery because it supplies DC power. It is not like a battery because the voltage supplied by the cell change with change in the resistance of the load. Solar cell made from a single crystalline silicon wafer. What about the history towards the solar PV cell? The photovoltaic effect was first recognized in 1839 by French physicist Alexandre Edmond Becquerel. However, it was not until 1883 that the first solar cell was built by Charles Freitas, who coated the semiconductor selenium with an extremely thin layer of gold to form the junction. The device was only around 1% efficient. Russell All patented the modern solar cell in 1946. Patent application of solar cell. Renewable energy can be powered for remote location. It is free, limitless, and environment friendly. More picture. Now the solar car, solar calculator, solar watches, solar aeroplanes, solar copters, solar drones. Physics of solar cell. What about the physics? Semiconductor material can be p-type hole carrier and n-type electron carrier. This is the p-type. This is the n-type. This is the p-type. This is the phosphorus and boron. This n-type is a donor type impurity, p-type acceptor होता है. This n-type is a positive ion, p-type is negative ion. N-type majority carrier are electron, p-type majority carrier are hole. N-type has impurity with an extra electron phosphorus, p-type has impurity with one favored electron boron. Put them together, PN junction. A solar cell is a very large PN junction or diode. Basics physics of solar cell. N-type, p-type recombination process. Holes from p side towards n side, or electron from n-type towards p side. The hole from the p-type side diffuse to the n-type side. The electron diffuse to the p-type side. This leaves behind charged ion missing electron or holes. Built-in electric field. The charged atom ion create an electric field. The electric field make it easy for current to flow in one direction but hard to flow in the opposite direction. This is the immobile ions. Both side they create depletion layer. Generating charge from the sun. Light breaks silicon bond and create a free electron and hole. Missing electron holes are passive charge. Built-in field separate electrons and holes. N-type and p-type like electric field creation. Generating charges from the sun. Connect diode to a circuit. Photocurrent goes through resistor, causes a voltage drop. Electric field. This is the photocurrent. This. Generating charge from the sun. Forward bias the diode, causes the current in opposite direction. Now biasing, and then this is the photocurrent. This is the biasing current. Generating charge from the sun. If R is very large, V is very large. If V is very large, IFB photocurrent and forward bias current equal to, then I equal to 0. Then I equal to 0, open circuit condition. Generating charge from sun. If R is very small, V is small, V is 0, IFB is 0, I is equal to IPC, short circuit condition. Construction of solar cell. They are constructed by layering special material called semiconductor into thin flat sandwiches. These are linked by electrical wires and arranged on a panel of a stiff non-conducting material such as glass. The panel itself is called a module. Modules are then interconnected in series or parallel or both to create an array with the desired peak DC voltage and current. How solar cell work? Function first, photogeneration of charge carrier electron holes in a light absorbing material. Function 2, separation of the charge carrier to a conductive medium such as a metal, contact, or a wire in order to transmit the electricity. It supplies a voltage and a current to a resistive load, light, battery, motor. Power equal to current into voltage. Third is the Now sun, and then this is the n-type, p-type, and then light glow. A solar cell is a sandwich of n-type silicon blue and p-type silicon red. When sunlight shines on the cell, photons like particle bombard the upper surface. The photons yellow dot carry their energy down through the cell. The photons give up their energy to electron green dot in the lower p-type layer. The electron uses energy to jump across the barrier in the upper and into the upper n-type layer and escape out into the circuit. Flowing around the circuit, the electrons make the lamp light up. Generic manufacturing of silicon panel. Now let us part 3 and we discuss more about manufacturing of solar cell. Thank you.